Hey, Evan,
Hello.
do you have any questions?
No, I just kind of came in early because I keep coming in late.
Oh, fun. Oh, can I do a little test on you? I want to see if this, if I can fix this screen share thing real quick.
Sure.
All right. Okay, so can you see this? Can you see Slack?
Yeah.
All right, and then now can you see Autodesk?
Yep.
All right, cool. It was only letting me do one window at once before, but I think I got it.
Huh. Actually, I do have a question or two about moving around inside of the workspace. So when you're using like the glow or like the rotate tool, for some
Yeah.
reason, like the center point is always off of the object that you have selected. Is there a way to make it so it's on it, like so you're focused in on it?
Oh, you mean like when you're using the box in the top right of the screen?
No, I mean just when I'm rotating. Like here, am I able
Yeah,
to
you can
screen
screen share.
where's that? Hold up. There you go.
For
Follow me.
the
That is.
bottom in the middle.
Oh, yes, that is where it is. Okay. So like when I shift and then rotate, it like see it's like rotating around this.
Oh yeah.
Is it just rotating around
So
the point that I have selected?
yeah.
Interesting.
I see what you mean. So Jacob and I both do it different ways. So what you can do is like see the hey, one second. Let me see if I can see the box right there at the top right.
Yeah.
So what you can do is you can click that and then hold down while you're clicking it and then move the object around. See it like that. So it takes a little bit to like get good at it, but
Yeah.
that's how Jacob does it. And then how I do it is I just have a 3D mouse.
Yeah.
So that helps. But yeah, and so you're using the shift and then click the center wheel of your mouse, right?
Yeah.
And you're doing that. Yeah. So that's another way to do it. And then there's also a rotate tool up here. I mean, well, you can't see my mouse.
I can see it when you draw. That's interesting.
Right there, yeah. So, oh wait, no, you got the wrong thing selected. So that tool lets you, let me admit this. That tool lets you rotate one piece of your thing, one piece of the sketch. So that's kind of useful too for rotating around. All right. Get started in a little bit here. Let's a few more people coming. Okay, so I guess someone else is going to join, so I'll go ahead and start with the presentation. So, first, I guess while we're waiting for people, for sponsors, and that's very helpful. GPS, AXA, Griffith Engineering, and Vision Metals. So this is the commands and tools review that we taught y'all on Wednesday. So first thing is a new part. And if you'll look at the picture right here, there's this little red dot. That's how you just click that and then it gives you a new part. So, and then multiple part files make up an assembly file. And then a new sketch is a 2D sketch on the plane of your choice. So these are the different planes that you can choose from. And you just click on it and it starts a 2D drawing on that plane. Next, a rectangle. That is a command inside of a sketch. So you can basically just click the top left corner of the rectangle and the others in the opposite diagonal corner of the rectangle. And there's also another rectangle tool that I'll show you today. And then to finish off the rectangle, you click enter on the keyboard and then you can dimension it and constrain it how you want to. Next, extrude. So this makes your 2D sketch 3D. And Yeah, so you can, so this is the kind of the like little menu of everything you can do. So profiles right here, that's your sketch. From one sketch plane, that's the plane that your sketch is on. Usually Autodesk will automatically select these two things, the input geometry. So it's obviously that way. Behavior is these little drawings right here are the directions that you can go. And then the distance is how you want to extrude it. Then past that, we won't be using that in FRC CAD. And then just click OK to finish it out. And then next thing for review, replacing a file into an assembly. So you can basically, assembly is a bunch of part files that you add in. So you click this little button up here, place, you click the file in your normal file system, and then it puts the file in there. And then so that you, and then once you place one file, Autodesk will keep placing files every single time you left click. So to get off of that, you click the escape key like on your keyboard. And then constrain. So this is basically the glue of an assembly. So there are 5 types, and I'll cover them real quick. So the little pictures here are pretty self-explanatory. Basically, this is mate or flush. It puts 2 things together. The second one right here is an angle. So it creates an angle constraint between 2 things. So if you have like a 60-degree angle, you can do that. This one right here is, the third one is tangent. And that basically puts a circle tangent to another face. So if you have a circle, it will go like that. And then the fourth one, this picture is kind of strange, but what it basically is, it's an insert constraint. So this constrains, if you have like a circle, and you have another, if you have a tube and another tube, you can put them together and constrain edge to edge. And then this last constraint we'll be using FRC. And, oh, very important, make sure to ground one component of your assembly so your parts don't fly around. So if you don't do that, then, and someone tries to edit your assembly, it'll just start flying. It's really bad. Okay, so that was the review, and here's the new stuff. So the new tool that we're going to be using today is a hole tool, and it, what do you know, creates holes. So it's in the 3D model tab, and you click hole, and then you basically just click where you want the hole to be. This is the second picture. And then there's this same kind of menu thing where you can click on what type of hole, the end, how deep, and the direction. Next thing we're going to be doing today is sheet metal. So here's a little diagram of what sheet metal does. So you have an assembly. That's like the main thing in Autodesk. And then a sheet, and then you can put different things into an assembly. You can put a sheet metal file or a part file. And a part file is what we've been doing. A sheet metal file, basically, you can make something curved, and then sheet metal will show you the dimensions of it in a straight. It's pretty useful. And then a mid-plane, we'll also be using that today. It basically creates a plane, which is that little orange thing right there, in the middle of 2 faces, so you don't have to do that. And then finally, the design accelerator. And that's basically this thing that makes it so you don't have to import files and automatically constrains things for you. So it's like the computer part of Autodesk. We'll be saving that for tomorrow. So here's Autodesk. So, all right, so this is our drawing. We have it going up and down right now. And, oh, sorry, I forgot to ask. Does anybody have any questions about the presentation? Okay. So, all right, first thing we're going to do is make this a little snazzy. So go to the view tab, click visual style, and then click realistic, and that'll make it get away all those drawing edges. Second thing is click shadows. So that'll make it look like it's a real thing just sitting there. So anyways, that's what we do to make it look more lifelike. And that's really good for like presenting and things like that. So first actual CAD we're going to do is we're going to go over here. Can y'all see my mouse? All right, cool. Just making sure. So click part right here, creating a new part. And this is going to be the top of the bike stand. So click and start new sketch, and then I'm going to click right here, XZ plane, and then create a rectangle. So the rectangle tool is right here. And if you want a different type of rectangle, you just click this little arrow thing, and there's all of these different types. But this one is the generic. So we're gonna go over here, and we can type how big we want it to be. So I'm gonna make mine 8. So I typed 8 on the keyboard, tab, and then 8. And another thing that you guys think about is your sketch constrained? So constraining means, so like if I delete that dimension, my sketch can go right all over the place. And down here in the taskbar, Autodesk will tell me, hey, 1 dimension needed. So I can do another dimension. Oh, another dimension. By the way, helpful like a shortcut. Shift D is a dimension, so you don't have to go up here and keep clicking dimension. So since we want this to be a square, what we can do is we can double click on this edit dimension and then click this one. So now this dimension is kind of like the master and this one is kind of like the slave. So if you click this and now type 9, they both change to 9. So that's helpful for editing. So finish the sketch, and then we're going to do extrude up here. And the shortcuts, so if you hover over anything in Autodesk, it'll give you like a little thing of what it does. But the shortcuts, the helpful one for this is if you see extrude and then parentheses E, close parentheses, that means that if you click Shift E, it's extrude. So that'll just help you add faster. So the distance that we're going to extrude it is going to be 0.125, so an eighth of an inch. Oh, never mind, that's 0.25, so it'd be 1/4 inch plywood. And then I'm going to go up here and then click this to turn it into plywood. We're going to go down, all the way down to white oak. So it's pretty good. All right, so right now we have a piece of plywood, pretty generic. And to make it look a little bit more lifelike, what we're going to do is put a fillet on it. So fillet is this tool. It adds rounds to 1 or more edges or faces. So click that. And fillet has all of these different commands that you would use, but right now what we're going to do is look at this select mode. So you can click an edge, so that would be on the fillet that edge. You can click a loop, which is like a, in that fillet's a whole loop. But to make it go faster, what we're going to do is click feature. And this fillets the entire feature. So apply, and now it looks a little bit fancier. So maybe that fillet's too much. So to edit a fillet, you go over here, double click on fillet, and now we're going to say 0.0625, so the 32nd of an inch. So that looks more like how we would want it to look in real life. So save. I'll go to where these files are saved, and then this is the top. And then go back over here to your full bike stand. Place. Have a lot of files. Outreach, bike stand, and then double click on top wood, click, and then what you're going to do is click escape on the keyboard. So now what we're going to want to do is constrain our piece of wood to the middle of this post. So we could do math and say, you know, what is it, 8 minus 1, 7, 3.5. But instead, what I like to do is do midpoint. So that was in the PowerPoint. So I just went back to the file top wood. So now we're back in the part file. And then go over here to work features, click the down arrow, and then click midplane between planes. Midplane between 2 planes. And this basically creates, you click one face, you click another face, and look, now there's this thing that we call a plane. That's a plane. So it's basically a 2D little thing that lets you constrain things based off of it. So now we're going to create another midplane. Go right here, and then go right here. So now we have 2 planes right in the middle. So then we're going to go over here to this file. Click up. A helpful thing, sorry I forgot to do this, but there's like, in CAD, there's like 5 different ways to select every command. So you just choose which one you like. Like, remember yesterday when Jacob wanted to edit sketch, he would go over here and then click, and then right click, and then click edit sketch. But instead, like my way of doing it is I click the plus arrow and then double click on sketch. So it's the same amount of clicks, same amount of time, but we just do it differently. So here, what you can do is right click and then click open, or you can come over here and double click. So, oh, no, that, I'm crazy. You can't do that. I click open, and then what we're gonna do for this file is do some more midplanes. So you're probably thinking right now, wow, this is taking forever, you could have just done that. But what is good about doing it this way is that, okay. Okay. What's good about doing it this way is that you can edit your CAD lines here. So math may be faster, a little bit faster, but in the long run, usually this works out well. So, oh, sorry, I'm automatically counting this. So, I have like little shortcuts on the mouse, so I'll have some use this. What you do over down in more assembly, a little review from yesterday, click constrain or Shift C. So here's the 5 type of constraints we saw in the PowerPoint. So we're going to use mate. So a work plane kind of acts as like a face, a 2D face. So we click that, and then click this plane, and then click apply. So next we want this plane to be constrained to this plane. And then apply. And then now we can see that it can move up and down. So we want to constrain this to this. And now when we move this, it moves with it. So now that I'm looking at this, I'm thinking, wow, the top plate looks kind of funny because it's just sitting up there. It's a little bit too small. So now I'm going to go over here, back to the sketch. And then remember we had the master and slave thing. So click 9, finish. And what's cool about the midplanes is they're still in between the faces. So if I go back over here, and then this little thing is update, now it's 9 by 9 and it stays in the middle and the math. So that works for people that don't like to do math. So next thing we're going to do is start making the arms for the bison. So Jacob had a little sketch here that I want to show, which is pretty good. There we go. And this doesn't actually reference anything in the document, but it does help. It does help show how long we want our arms to be. So based on this, if we move this thing up, we want when these two lines are parallel, we want this arm to be contacting somewhere around right here, because that'll stop the bike stand from just flipping back after you get your foot off. So 6 inches is the dimension we're going to use. So what we're going to do is click New right here, and then Part, Start 2D Sketch, and then choose this one. And then do another rectangle. This one, remember, needs to be 6 inches long. We're going to make it 1/2 inch thick. And then we could just leave it with the ends squared off, but in my opinion, I like it to be kind of round because it looks cooler. So you're going to, new command. So you're going to click arc right here, an arc is just an arc. So a 3-point arc means that you click one endpoint of the arc, the other endpoint of the arc, and then you move the mouse around to choose like the diameter of the arc. So I'm going to use that command. Click one point, click the other point, and move it out. So I don't know if you can see it because it's kind of small on my screen, but see those little tiny white things above each intersect? That means that it's tangent. So that's what makes it kind of like a round face in a round. Because otherwise, if it wasn't tangent, then it would look kind of funny because it'd be like that. And that looks bad. So I'm gonna wait until I'm gonna do the little white tangent symbols. Next, we're gonna come over here, do the same thing. Okay, so now we have our little. Next, we're gonna finish sketch and then extrude, and then we're gonna click this, that. So it looks kind of funny right now. It looks like a key on a motor, but instead we're going to extrude it at 0.25. Because for the lift arms, if we actually build this, we want them to be like thick steel because there's going to be a lot of force on the ends of them. So click OK. Now we're going to go over here and then go, I think last time we used steel, it's like cast. Nope. Steel polished. There we go. So what you're going to do next is what we talked about in the PowerPoint, which is a hole. And then click right where you want the hole. And then next, another one where you want the hole. So you're probably wondering why I chose 0.26. So if go back over to Google and type in clearance hole for quarter 20 volt. And we'll go to a clearance chart, and I'll teach you how to read this chart. So basically, a hole has two things that describe it. The first one is it's like a kind of like a reading of what the bolt is. So you can have like 5, 8, or 1/4. This is the screw size this is the screw size right here. The second one is how many threads there are in an inch. So in FRC, you probably heard when we say we want an 832 bolt, that means it's a screw size of 8 and there's 32 threads per inch. So in this case, what we're going to be using is a quarter screw size with 20 threads per inch. So now we're going to be using this right here. So quarter to quarter 20. And then go over here and we want a free fit right here. That means that it'll be 0.266. So now we'll go back over to CAD, and that's why it's 0.26. And the reason I'm not saying 0.266 is because we don't have a drill bit that's that accurate. And if you're putting a bolt in and there's 0.006 of an inch off, you're not going to notice. So that's why I put that there. All right, so okay. And then now, if we look at the sketch, we're like, oh dang, these holes are really off. So go, oh, I'm sorry, I did that too fast. So over here on hole, you can click the plus sign, go to the whole sketch, and now wherever that hole is this dot. So see if I move it over there in the sketch, the hole moves over there. So what you're gonna do is do something called project geometry. Yeah, so project geometry basically means that you have a solid and then you turn it into a sketch again. So sorry, that's kind of complicated. So click it, and then if you put your mouse over this, click that. What it'll do is draw lines where all of the cuts are in your sketch. See, the lines are all over the sketch. So the reason we're doing that is because we want this dot to be on this dot, which is the center of the arc, so it all lines up. So to do that, we'll do a sketch constraint. And sketch constraints are basically, remember how in an assembly we could do like mates and tangents and inserts and all that stuff? So this is the 2D version of that. So if you hover over it, the one that we'll be using is a coincident constraint. So it constrains a point or a line to another point. So constraint, click. So you click the little thing, click the point, and click the dot. Now we're going to go over here, click the point, click the dot. Finish sketch. Now our two holes are right on, they're centered on the curve. So now that we're done with that, we'll save it. And then over here as lift on. And then we're going to go to the assembly, again, place, and then lift on, open. And for this, we're going to want 4 of them. So once, twice, 4. And then escape to deselect. So what we have to do is, here, I'll pull up my bystands. So you can see. Wait, never mind, I don't know where it is. So actually I can just pull up Jacob's bystand. So Jacob has this little bracket right here that connects the lift arm to the central pole. So that's what we're about to do. So for this thing, what we're going to need to do is, for this little bracket, we're going to click New, and then Part. Start another 2D sketch on this plane. And then we will be clicking, first we're going to make a rectangle right here. And this rectangle needs to be 1 inch by 2 inch, 1 inch by 1.5 inches. And then we're going to do a line right here, another line, and then another line. So basically what we're going to be doing is creating kind of like a little offset thing that the bolt can go through. So we're going to click dimension, click this, and then click this line, and it'll automatically go to the angle, which I want to be 120. Then I want this angle to be 90. And I want this angle to be. So I'm going to push this in a little bit. And then next we're going to create a dimension from here to here. So right now it's creating a vertical dimension, and then if you move over here, it'd be a horizontal dimension. But I don't want that. I want it to be in line with the line. So I'm going to right click and then click Aligned. Now, say I want this to be 2 inches long. So we're going to click Finish Sketch, Extrude, click on the 2 sketches. And this needs to be 0.125. 1/8 inch steel. And go up here, S, and go down to steel polished. So next what we're going to do is make some holes. So we're going to click, we want 3 holes. 1, 2, 3. Then we're going to click, double click on the hole sketch, click dimension, project geometry. So you're going to click that. And then dimension, and then click from here to here. We want it to be a 1/2 inch. From here to here, we want it to be another 1/2 inch. So we'll click that. And then from here to here, let's see. So, okay, so that was an important error. So if you try to dimension from here to here, it won't let you. Adding this dimension will overconstrain the sketch. Choose accept to create a driven dimension. So basically Autodesk already knows that this distance from here to here is 1.5. So by doing subtraction, it already knows the distance from here to here is 0.5. So we don't need to make that last dimension. So here again, we can make this one 0.5, this one Okay. So this one right here needs to be, let's make it 35. This one. And then we also, when you go into this extrusion, figure out how long this piece is. 0.75. Back over here, this. So this one needs to be, again, 0.35. It needs to be 75. Okay, now finish the sketch. There were holes there. So this bracket right now is kind of chunky. So what we're going to do is click fill it to make it look nice. And this time we're going to use an edge. So we want to fill it this edge, this edge, this edge. And in real life, this would be using like a belt sander to assemble. So let's try 0.25. That looks pretty good. 0.5. About 0.3. That looks a lot. So as I'm looking at this, these holes look pretty close together, and I'm just like from experience, it'd be pretty hard to fit a 1/4-20 bolt right there. So I'm going to go back into the hole, the whole sketch, and make this 0.35. This, and make this 0.35. Also, there we go. So that's a problem because now, since these are all slaves, it's one is controlling all the other ones. I still want them to be 0.5, so I have to go in and do the divisions. Okay. Got that bracket done, so we're going to click save and make this side bracket. And then go back to here. And we want to place the side bracket. For this, we want 2 of them. So, all right. So right now we can start constraining. So constrain. I want to constrain this bracket right here, with this face. And then I want to do a flush constraint. I want to do a flush constraint from here to here. And then a final flush constraint from here to here. So now if I try to click on this bracket and move it around, it moves with the piece. So here we go. Next, what I'm going to do is constrain. Oh, here's an important thing that you can do. So Autodesk has this fancy tool that is called mirror. So what you can do is click that, click mirror, click this component, and then click mirror plane. And we want it to go right across this plane right here. So now, instead of having to constrain that entire other piece, what I can do is just click next. And then, I'm sorry, I clicked, wait. Okay, so my bad. Mirroring is only good if you're gonna ground something. So what I just did is I mirrored it, but Autodesk didn't know which constraints to make. So if you're mirroring something, you have to make sure that that thing isn't going to move. So mirroring is good. So in FRC, we don't really use mirroring that much for that reason, because a lot of our stuff is supposed to move. So, so to get another one of this, instead of having to click place and go find the file again, just click this, click copy, and click paste, just like you would in Word. So we're going to quickly constrain this thing, exact same constraints as before. It's on the other side. All right, so there we go. Next, we can use these things right here. So what we want is for this thing to be concentric to this pole. Yeah, concentric side. So what you're gonna do is, click this thing, this face right here, and then go over here and click this one. So now, see, it's right there. So, see, So now what we're going to do is click this face and constrain it to this face. So see, now this thing moves like that. So that's the first step of our little animation. Next, we're going to go over here and do the same thing for the second one. And then constrain that to there. But we want these to move in the same, right? Sometimes. So right there, you're seeing, oh no, they don't. So what you're going to do is use a flush constraint and flush this face to that face. So now, if we, I'm just going to lock this for a second so you can see what's happening. So see now it moves up and down like that. So, so now we're going to fix some of to make this more like real life. As you saw, I was moving it up and down like this. This wouldn't happen in real life because it's metal going through metal. So to make it more realistic, what you have to do is do another constraint. So constraint. We want it to go this face to this face. But if we do that, it won't be able to move. So Autodesk has this fancy thing that you can do is if you click these two arrows right here, you can click maximum and minimum. So on the way I constrained it, the main arrow is coming up, which means that the maximum I want it to be about 4 inches. So apply. So see, it'll go up to 4 inches. So I'm using the measurement tool right now, by the way. Measure, that's 4 inches. That's the maximum go. And the minimum is 0 inches. So see, it goes up and down, and that's it. So now I'm looking at this, a 6-inch arm is kind of fun. So we're going to shorten the arm over here and click. Let's make it 4.5. So we're still going along with Jacob's sketch because the arm lengths are going to be. So now you're like, oh, dude, all my constraints are messed up. But no, all you have to do is click this lightning, local update, check. And got it, they're constrained again. Okay. I'm not really sure why these aren't moving. So I'm going to go over here and click. We have one mate that's going through there, one to that, and one to there. We're going to try to delete that and see what happens. So we're going to redo that, and then hopefully our animation will still work. First, redoing the flush. Okay. It doesn't like that. And this is really annoying. So now we're going to try to, there's troubleshooting this. So what we're going to try to do is delete these. And then redo the constraints. And redo that constraint to that hole. And that one. Now, alright, we got our animation back. That was weird. That doesn't usually happen. If you do a local update, it should work almost all the time. So, next thing we need to do is make a little bracket that will hold these up in the air. Those. So, for that, we're going to use sheet metal. So, sheet metal is just another form. It's like another thing you can put in this. So, what you're going to do is go to File, New, and then click on sheet metal and inches. So now we have this sheet metal tab. So what we're going to do is we're going to create a simple L bracket. So we're going to start a 2D sketch right here. We're going to do another rectangle, but this bracket needs to be 1 inch by 1 inch. So I clicked 1 tab 1 on the keyboard and then so finish sketch. And then here's the cool sheet metal part. So what you can do is instead of extrude, sheet metal has this thing called face, which is kind of like the exact same thing. But instead, you can't tell the sheet metal how far you want to extrude it because you have to set previously how thick your sheet metal is. So the default in Autodesk is 0.12, and most of our sheet metal is 0.125. So 5,000 of each will make a difference in something like this. So we're going to click apply. And now we have this little, looks like a brick. So the cool thing about sheet metal is now we're going to go up here and click this new thing, which is flange. And then click an edge. So this basically allows you to draw curves really easily. And so that that command, when I click flange, and then if I click this one, the flange will go down. If I click the upper edge, the flange will go up. In our case, we want it to go up. So the important things here are, this is so these few things right here are how it measures the distance. So the default one is what we want. The bend position is again how it measures the distance between the two things. So that's again what we want. So click apply. And now again we want to change this to polish steel. So what we need to do is basically make two holes here. So sheet metal also has the same hole tool, so you're going to click right here. And we want two holes right there. Again, 0.26. We're going to go into the hole sketch. And then distance from here to here is going to be 0.5. 0.35. It's going to be 0.765 right here. And then this one, we'll just link it to the other dimension. And we can be able to edit it easily. Here, I'm going to make this 0.35. Here, and make this one 0.35. That'll make the holes a little bit farther out apart, so they're easier to make in real life. So next, we're going to need another hole. It goes right here. This one will actually connect the arms to the piece. So here, 0.76. Oh, the reason I'm doing 0.76 is because the distance from here to here, showing in 3D, distance from here is 0.76. So this is in the middle of that spot. So that makes it, so even though that it's not in the middle from here to like down there, it's not in the middle for 1 inch. In real life, it'll look like it's in the middle because it's just like an observation. So if we go over here, make it finish. So now here comes the cool part about sheet metal. So what you can do is you have this L bracket, and you can click create flat pattern up here. And then, so this makes it so that we can cut it out of a piece of metal and just drill the holes. And we already have the distance from side to side. We have the distance from the center of our bend. So that just makes it a lot easier to build. So to get back to the folded part, click previous folder. There you go. So right now, this bracket is kind of bad. So we're going to click fillet, and then fillet these edges right here. And we'll try to make this 0.25. Great, that looks decent. Save, and then this is going to be the bracket for arms. Okay. Place. Oh, sorry, you want to guys. Go back. Okay, go back to the full bike stand. Click place, and then click bracket for arms. Open once, twice, we have two of them, and then escape. So now what we need to do is figure out where to put these. So what I'm going to do is go into this tube, and I'm going to use planes for this again. What we're going to do is click mid plane, and make a mid plane on this. Okay. So now what we have is a grid clean through basically our entire drawing. So this is helpful because now we can do a little bit less math. So right now we're going to put here and here for constraint. This plane that we just made, and then this right here. So this is putting this little bracket right here in the middle. So I wanted it to actually have an offset of 0.5. Make it like that. There we go. And then drag this thing up. Now we want it to be put on this face right here. And now we also want it to be flush to this face. So now we have our little bracket there, and you try to drag it around, it can't move, which means that it's fully constrained. So the next thing you're going to do is get your second bracket, put it right. So right now, it looks like our bracket is going to be pointing the wrong way. We want it to point the other way, so we have more room for the lift. So if you want it to reverse directions, what you can do is just click flush. And now if we drag it up, it's in right spot. So again, we're going to constrain this right here. And then do a flush back to there. So now we have our two brackets, which are all nice. Next, we're going to do our lift arms. So right
Are
now,
those brackets supposed to be off center?
yes, no. Wait, I'm sorry, I forgot to do the offset in that. Thanks, Reese. So flush 0.5. All right, so now they're on the same. And then I'm going to click the center of the hole right there. And we want it to be through this one right here. We do the same thing for the other one. And then move them a little bit closer, because now what we're going to do is do a little bit of extra constraints. So what happens if we constrain this piece to this face right here, it's not going to work because it's a 1-inch offset the whole way. So if you do that, then we'll be able to connect it. So instead, what we have to do is go constrain this face to this face. And then this one and that one. And then we have to do a flush constraint from here to there. So now what we have is these pieces go up and down like that. These pieces go up and down like that. So what we have to do is link them together. So click there and then there.
If we were like to construct this in real life, would you use spacers to keep those centered?
Yes. So yeah, so like right here and then right here, you would have like a piece of like thunder hex or something like that. And right here to also do that. So in CAD, so if you're CADing like for a business, you definitely want to have all your spaces, all your bolts, all your holes. But in FRC, we don't have enough time to do that usually. And it's kind of like an extra thing that we don't really need to do. So we often just skip that part of the design and just think about, all right, there's going to be a bolt going through there. So, and then make sure that nothing runs into it, just like in our mind, there and see if it works. But instead, before I do the bolts, we're going to put some L brackets right here. So to do that, we're going to go into new part and then started to, I don't know why I just said new part from that. File, new sheet metal. Okay. We're going to make this time a 2x1 bracket. So, oh gosh. Oh, so that's something that took us a while to figure out. So what I just accidentally did is I just made it so I could see every single one of the files on my screen. So to do that, so we get back out of that, click maximize documents. So we do that. Yeah. So we're gonna make another rectangle, 2 by 1. Place it, same thing as before, hinge up. This time is to be 2 inches. Wait, actually, I think that look better if they're 1.5. That's what we did on the first one. So now it's going to be a 1.5 by 2. And then next, what we're going to do is put 2 holes right there. Same dimensions as before, so we need to go a little bit faster. That's what I'm going to do. And from there, it's going to be and then I'm going to do 2 more holes right here. So these are going to be like the L brackets for the like little cross pieces. The cross pieces on the bottom of the bicep and on the top. And 5, and it's going to be the same height. Alright, then I'm going to do the same. I'll pause a second so you guys can catch up. Alright, so we're going to do some more fillets right here to make this bracket look a little bit better. For that one. And then steel. And this is going to be a 2 by 1. Over here. Now we're going to place our 2 by 1 brackets right here, one right there, one right there. We also have to do the top too. So we want one right there and one right there. So again, we're going to be using the exact same constraints we've been using, just and we don't want this 2 by 1 L bracket right here, because then this bolt will go through where these ones will come down. So that was where I did. I'll just, we're not actually putting this type of L bracket right here because it won't work. So I'll just show you why we can't do it. So if we have bolts going down through here, they'll hit this bolt. So what we have to do is copy this L bracket and take out this hole so that we only have one hole there. So over here and delete the constraints for that. Alright, so using the same, we're just using mate and flush for this because it's some pretty easy constraint that you can do. There, and then we're going to do the exact same thing on the other side. Sorry. And there. So now it's partially connected. Next thing we're going to have to do is
Jonathan, I would say this is probably a good stopping point for today.
Yeah.
It's like in like 52 minutes.
Yeah. So we'll just finish up, do all the bolts and the handle and all that stuff on Monday.
Does anyone have like any questions about what happened? Is anyone lost anywhere right now? I'm good.
All right.
No, I just want to note when you resized the top, it didn't recenter, or at least for mine it didn't. I don't know if it did on yours. But it did.
Since from here to here should be 4.5. Yeah, at least around mine. You wanna share your screen so I can see?
No, I fixed it. I just redid it, but it just wouldn't recenter by itself. Where was the local reset thing or local update?
Oh, it's right here.
Ah, okay.
Look.
That might have been it.
Yeah, sometimes if you try to update parts and sometimes the assembly kind of freaks out, especially like in our robot when you have like a few thousand parts in there and it doesn't happen. So any other questions? Alrighty. Then we'll see you on, oh, Alan, how do you do the master thing with the dimensions? Well, I don't know what that means. Jacob, do you know what he's talking about? Jacob? What's a master? Like where you have one side. Oh, my bad. I know what you mean. So we're gonna go into this to show you. Oh, not screen share. Screen share. So go over here to this one. So how you do it is, so you just made this rectangle. What you're gonna do is click dimension, and then one side, and you want this to be 9 inches, and then you click the other side, and then so right now we're on the dimension editor. What you can do is click this dimension, and click OK, and now it's like the master thing. So say we want to edit this to make it 8. Now this one becomes 8. Did that explain now? All right, cool. So we'll see y'all on Monday at 1:30.